Welcome you all in the technical lecture series by National Center for Technical Services, an arm of the Institute of Indian Foundrymen. Today's session will deal with organic binders systems for mold and core making. Mr. R.D. Dhumal, a well-known figure in foundry chemicals, will take us through this. After completing his MSc in organic chemistry way back in 1974, Mr. Dhumal joined Ajay Metachem Private Limited, and during the tenure of around 38 years, he reached to the position of SBU head for foundry products. Since 2012, he is working as technical director at Seraflex India Private Limited. He has achieved many laurels in developing many resin formulations for critical mold and core making applications in different processes such as shell sand, humidity resistance cold box, pepset no bake, and warm and hot box process, both for ferrous as well as non-ferrous foundries. Let us hear more about the subject from a person who have traveled extensively to various foundries worldwide and a regular visitor to GIFA. I now request Mr. Dhumal to take over. Thank you.
Thank you, Director, Mr. Satish Somani, and all participants who are here. So, good evening. In a foundry process, melting is one process, molding core making is another process, and third one is the fettling, where we are getting the end results of our operations. So, in between is the molding and core making, where sand molds, other molds are used. The cores of sand cores are used, and to prepare this kind of the molds and cores, various kinds of binders are used. Category binders may be inorganic, like a sodium silicate, may be a hybrid, which is a blend of the organic and inorganic, may be purely organic. No doubt, each binder's category is having certain advantages and disadvantages towards the castings. And worldwide, organic binder systems are more popular because of their better properties over other binder systems and better casting results and productivity. These are the three things, important things for the popularity of the organic binder systems all over the world, adopted by the various foundries, ferrous as well as non-ferrous foundries. Actually, we'll go through these kind of the things. First, introduction. Then, main ingredient is the sand. Almost 95 to 99% is the sand constituent in any molding and core making process. So, sand is also important factors. Then, various binder systems used by various foundries, in both the cases, ferrous as well as non-ferrous, will go with the various binder systems. And no doubt, because of this, what kind of the casting defects are coming and what are the reasons for that we will try to cover. Now, what is the requirement of the core or mold for the best casting results? Requirement with respect to the binders. First thing is the binder constituents should have better miscibility with the sand, because some of the binders, sand grains repel the binder and uneven coating will be there. So first criteria is the most important, is the good mixability of the binder components with the silica sand for the better results. Better results with respect to the surface finish of the mold, surface finish of the core, and indirectly surface finish of the casting without any defects. Then, excellent flowability and suitability of the prepared sand. Some of the binder systems like this self sand, then to some extent cold box, then other binder systems. The cores, basically these binder systems are used for making the cores, where cores are made by the core shooters. So that binder system should have better suitability for the better compactness of the core. Then one more important thing, in Indian foundries, the culture is like that. Today we prepare the cores and we may use after 1 hour, 1 month or like that. So foundryman expect a longer storage or shelf life of the cores. So wastage will be less. Then during the molding or making processes, because of the air pressure, because of the some separation of the binder components from the sand grains, deposition on the pattern surfaces are there. So normally customer or foundryman expect no deposition or minimum blockage over the tools or patterns should be there, so that downtime will get minimized. Then now in case of automobile foundries, number of molds, number of cores requirement is very high. So design binder system should be in a such that the desired targets of the making the molds per hour or per day and making the cores per hour per day should get achieved. So that binder system should have faster curing phenomena to achieve the targets. Then most important, we are always talking about the distortion, dilation, and all these things. No doubt, silica sand is the main culprit in that for the distortion and dilation and deformation. But a secondary expansion is caused by the thermal dimensional stability of the binder. Some of the binders are having some distortion characteristics. So one should understand this thing, because the cores used for making the casting like cylinder head, cylinder blocks, where jacket, water jacket, oil cores are used. There, this phenomena is important. Then, most important, no gas or porosity related defects. Your design binder should have as low as possible gas evaporation. Otherwise, casting will get rejected due to the gas porosity, blowholes, like that. A number of things are there. No doubt, at the same time, one has to look towards the sand quality, not only binder. Then, in case of particularly non-ferrous castings, aluminum, low melting alloys, sand sticking on the casting is observed. So, design binder system should have a characteristic that there should not be any sand sticking over the surface face of the casting. This phenomenon is observed particularly in case of the aluminum castings. Whereas, being a high temperature, this kind of phenomena is not there. Then, no doubt, good checkout after pouring the casting and cooling and all this thing, all the material should come out from the casting very easily. And nowadays, we are talking about the environment, ecology, and all these things. So same sand should get recycled, means by the way of the reclamation process. So this binder system should have a good reclamation, easy reclamation characteristics inbuilt. And excellent surface means of the casting. Why we are paying more for the binders, more for the silica sand to get the best castings with a minimum rejection and no rejection. Now, selection and quality of the silica sand plays vital role for best casting results. As initially I told, for making the molds and cores, we are using 95 to 99% of the silica sand. And most of the foundries are neglecting the quality of the silica sand. They are more emphasizing more on the quality of the binders. So silica sand is also equally important for getting the good casting results. The sand behavior is decided by grain shape, smoothness of the grain surface, density of that silica sand, what kind of the impurities are there, sieve distribution. We are talking about the 3 sieve, 4 sieve distribution, bell shape graph and like that. Then FS number indirectly tells about the grain distribution as well as grain size. Then segregation of the silica particles during the transportation from one place to another place during the sweating. Some separation of the sand particles are there that also affect the quality of the molds and cores. Then durability. Some of the Indian sands are fragile and they don't withstand against the thermal shock. So durability is also important. Means more of the fine generation is there, and that may result in the inclusions in the castings, sand inclusions in the casting. Then expansion at the high temperature. This is most important factor for the cores used for casting like a cylinder head and cylinder blocks. Then some of the hydraulic castings, because you may observe the dilation or deformation. So expansion at the high temperature is also important as far as sand is concerned. Then sand temperature, this is important for all kind of the organic binders because most of the organic binders contains solvents. Most of the organic binders, some of the no-bid binders are cured at the room temperature, where this sand temperature plays a vital role. Then fines in the sand, anything passing through 140 mesh are the fines, and fines are always non-wettable towards the organic resin binders. Means more the fines, more binder requirement will be there, and that fines will definitely affect the permeability of the mold and core, and excessive gas evolution will be there because of the low permeability and higher demand of the binder components. Now, first characteristic is the grain shape. Normally, we are talking about sand should be round, it should not be angular or like that. So, available sands are having the grain shape is either rounded, angular, subangular, or compounded. Means mix of the angular and rounded. Angular sands require higher amount of the binder because surface area is more with the angular sand. And angular sand always shows less permeability and they are having the lowest pliability and very difficult to make the cores with the core shooter when we are using the angular sand. Good example is in Maharashtra, Kondaghat sands are angular. Hyderabad, the part sands are angular. The sands which are prepared from the silica sandstones by crushing, they are normally angular. Compounded grain sands requires higher amount of the binder because of the higher surface area, and they are having the tendency to disintegrate at the higher temperatures. Means they don't sustain the thermal shock, and that results in the fine generation during the casting process. Whereas rounded grain sand requires less amount of binders and they are having the excellent permeability because of the less contact area, grain to grain contact area is very less, very minimum in case of the rounded grain sand. A mixture of the rounded, angular and subangular sand grains is used to control the permeability and strength. No doubt rounded grain sands, though they require less binder content, but they are prone for the failing tendency in the casting. So it is advisable the mixture of the rounded and angular subangular sand to use for making the molds and cores for the better casting results. Then second characteristic is the grain surface. Normally, silica sand grain, when you observe under the microscope, you will find some of the grains are very smooth. Some are having a rough surface and some are wrinkled. Irrespective of the AFS number as U distribution of the silica sand, the smoother grain surface sands give out the worst results because there are poor adhesion of the binder components over the grain surface. Whereas wrinkled, rough grain surface sands give the best results. These are the photographs of the rounded sand grains. You can see there is no angularity. They are means all the corners are towards the round. This is a photograph of the mold. One is made from the using coarser sand, another is with the fine sand, and you can see the cavities in between the sand grains. And same thing is going to reflect over the casting surface of the surface. These are the some of the photographs of the sand grains. First column is the very high angularity. You can see the sharp edges. Second is the angular, subangular, sub-rounded, rounded, and well-rounded. You can see the difference between the angular to round. Then this is the chart comparative properties of the various sands used by the Indian foundries. Silica sand is from India. Many sources are there. Zircon sand is from either Australia or South Africa. Chromite from South Africa, and olivine from India. The silica sand, normally whatever we are getting, they are either whitish or like brown in color. Zircon are white to brown. Chromite is always blackish, and olivine greenish gray. Bulk density, you can see silica sand is a lighter one compared to other sands. Zircon is having the highest bulk density. That's why zircon sand always requires less amount of the binder compared to silica sand. That is the main reason. Then we talk about the thermal expansion and distortion. Here you can see the thermal expansion at 1600 degree with the silica sand is 0.018. Zircon is a 0.003. Chromite is a 0.005, and olivine 0.008. So zircon is having the very less expansion, thermal expansion. Then fusion point. Fusion point depends on what kind of the impurities are there in the silica sand and any other sand. So that's why I mentioned fusion point of the silica sand is right from 1425 to 1760 and 16 degrees Celsius. Some of the poor quality sand gives the problems like a sand fusion or like that because of this. Then SKU distribution, whatever Indian sands are available, having 2 to 5 consecutive SKU retention. Other sands are zircon and olivine are having a less consecutive SKU retention, but chromite is having a gain wide band. FS number available with the Indian sand is right from 25 to 120 numbers. Zircon, normally it is a fine, it is available in the range of 70 to 160. Chromite is a 40 to 90, and olivine sand 40 to 120. Then now chemical reaction. We are talking about the acid demand value or pH value of the silica sand. Normally, Indian silica sand are acidic to neutral in nature, but during the washing process, if that mine owner might have used the alkaline materials to remove the clay, that sand may have certain alkalinity resulting in a high acid ADV, yeah, high pH towards the alkaline. Zircon sand, there is no question. They are normally acidic to neutral. Chromite is a little bit of basic in nature, and olivine sand, it is always basic in nature. This is the chemistry of the various Indian sands. Mangalore, once upon a time, Mangalore sand is supposed to be the best, but now the availability is the big question mark over the Mangalore sand. After that, Godur sand was more popular for the Indian foundries, particularly southern India, southern part of the India. Then Allahabad, that kind of Allahabad sand is used by the northern India and eastern India. And nowadays, recent development is the Ankleshwar, that is a Gujarat belt sand. It is used by almost Gujarat, Maharashtra, then I can say Chhattisgarh and all these countries. They are using the Ankleshwar sand. And some of the foundries in Karnataka district also. Then Fonda, that is from the Maharashtra, it is a mine sand. It is used by most of the nearby foundries like Kolhapur, Belgaum. Foundries are using Fonda sand. Here I have not mentioned the Serateri sand, that is from the Kerala, because availability is the big question over there and it is not economical. If you see the chemistry of this sand, ferrous sand, alumina, Al2O3, these are the impurities, Fe2O3, impurities, MgO and calcium oxide, MgO and CO, they are the culprits for the sand quality. They indirectly, if you check acid demand value, you will come to know about the magnesium oxide and calcium oxide. And higher the amount of the magnesium oxide and calcium oxide, the sintering point of sand is less, and that may result in casting defects like the sand fusion or like that. And one more thing, being alkaline earth metals, acid demand value of this sand contaminated with MgO and calcium oxide will be more, and that will affect the binder performance. Then most important is simple test, loss on ignition. That is a simple test to check the impurities in the silica sand or any other sand. Higher the loss on ignition of the sand means that sand is having the higher amount of the impurities. So normally ideal sand should have loss on ignition in this range. For Mangalore sand less than 0.5, or Godur less than 0.7. Godur I mentioned here unwashed sand. Washed sand may have a less loss on ignition. Allahabad sand less than 0.3, Ankleshwar less than 0.2, and Honda less than 0.5%. pH indirectly tells about the acid demand value. pH means it's a 10% mixture of the silica sand, dry silica sand and distilled water, and that indirectly gives idea about the alkalinity, acidity of the silica sand, and one can decide binder content or binder quality after checking the pH value of the silica sand. The AFS numbers of these various kinds of the sand I have mentioned in here, over here. Most of the sands are fall in the range of 50 to 60 AFS number, but there are some suppliers, they can supply sand as per your requirement, either coarser size means 30, 35, 40, 45, yeah, 65, 70, 75, 80 like that. And this is the most culprit last point, fines. You can see the fines are more with the Godur sand, Allahabad sand, Ankleshwar sand, and Fonda sand. So one has to take precautions for the fines for the better results. As I told earlier, these are the various binder categories used by the Indian foundries: inorganic, hybrid, and organic. Inorganic binders are normally sodium silicate. Each and every foundry is versatile with sodium silicate. then sulfates, phosphate, hydroxides, borates, then hybrid binders like Amcol, Log, Sirathum, like that. This is the character. We are not going to highlight on this. These are the binders of. These are the various binders, the binders with the advantages and disadvantages. Sodium silicate is widely used by the Indian foundries. Most of the steel foundries are using the sodium silicate as a binder. But when you go use the sodium silicate as a binder, you will find a lot of problem with the shakeout, then quality of the molds and cores because they are hygroscopic, and no doubt surface finish of the casting is always rough, irrespective of the huge amount uses of the huge amount of the coatings. No doubt, inorganic binders are having the low emission, low odor, then gas variation is also less, gas related defects are less, they are having the good thermal resistance. So dilation and all these things are not with the sodium silicate. This is one more binder, hybrid binder. It is especially developed for the aluminum castings where shakeout is the big issue. This is a unique binder system used in aluminum casting. It is having no smell, no fumes, irritation, nothing is there. Just prepare the mold or core. Basically, it is used for making the cores only. And for the casting, there is no gas evolution, nothing is there. And 100% sand can be reused for making the next process. Now we have come to the main topic, organic binders. Some of the foundries, European foundries, are using the protein binders. Then most popular is in India, phenolic and furan resins. Phenolic and furan binders, we are calling as the resins. Of these phenolic and furan resins are widely used by Indian foundries. And of this, based on the curing mechanism, these binders are categorized as a thermoset or heat cured, no bake. No bake means curing at the room temperature, and gas cured, or this part is the cold box also. Now coming to the organic binders main topic, heat cure binders. Among these, first I have chosen the hot box or warm box. In old days, the foundries like a DCM, or Mahindra and Mahindra, Kandiwali, they were using the hot box process for making the particularly critical cores. This is one of the best process once upon a time, replaced by either cell or cold box. But recent years, the same process modified, it is called as the wall box process, is adopted by various aluminum foundries for making the cylinder heads for the four-wheeler. Good examples are the Tata Motors, Suzuki, Jasin, then ordnance factories, they are using this kind of the binders. The binder is the phenol formaldehyde copolymer or urea formaldehyde copolymer. It is a three-component system. One is the hardener, another is the conserver. Conserver is nothing but it is a lubricant and it repels the water, and thus it extends the shelf life, storage life of the cores. And it helps for the better miscibility of the binder resin and hardener with the silica sand. The binder is the environmentally friendly because one of the components is the purpur, which is the agro base, and hardeners are the only salt solution. Nothing is hazardous in this. Users normally foundries are using 1.52% of the resin based on the sand, hardener 20-25% based on resin, and conserver 20-25% based on hardener. Being a wet process, you will get bench life of a mixed sand for 1 to 2 hours, depending on the type of the sand, quality of the sand, and ambient conditions, and how you are going to store the mixed sand. So it varies from 1 to 2 hours. Then curing temperature means the temperature of the pattern is a 180 to 220 degrees Celsius. Curing time is a 30 to 90 seconds, means productivity is much faster. Hot tensile strength is 6 to 8 kg cm square. Basically, this binder system is used by the aluminum foundries. So, purpose we have means hot tensile strength is controlled at the lower range. Then cold tensile strength is 10 to 15. Gas evolution is lesser than the cell process and any other binder, organic binder process. It is a 9 to 12 cc. And cell life of the core 2 to 3 days when relative humidity is less than 60, and 1 day when relative humidity is more than 60. And that's why cores need to warm in oven before use. Yeah, one can store the cores at little with the elevated temperature in a core house. Then, what are the advantages of this process? It is a fast, 30 to 90 seconds is the curing time. So high productivity you are getting. Lower curing temperature than the cell process. Cell process you get normally require around 240 degrees of the temperature. Here it is a 180 to 220 degrees Celsius. So energy consumption will be less with this system. Then excellent dimensional accuracy of the cores and castings. Because 100% curing happens inside the core box itself. So dimensional accuracy is fantastic with this. I can proudly say all the cars running on the Indian roads having the aluminum cylinder head, all the cores are produced by using this kind of the process. Ideal process for the thin and thick wall casting. Normally in curing material, what happens when section thickness of the mold and core is more, chances of undercure remnants are there. That is not happening with this process. Irrespective of the cross section of the core, you will get the uniform curing. Then it is having comparatively high strength with a low gas evolution. So gas related defects are very less with this process. Then excellent shakeout, no additional heat is required. This process is exclusively developed for the aluminum type of aluminum castings. So shakeout characteristics are well addressed by developing this type of the process. So shakeout is excellent. Then comparatively it is cheaper than the cell process. No doubt, like advantages, some disadvantages are there, like irritation during the sand and core preparation because it contains some free monomers, so irritation is there. Then limited shelf life of the cores, as I mentioned, when relative humidity is less than 60, you can store 2 to 3 days. When humidity is high, 1 is on the same day. Shelf life is less than 1 day. Then core humidity resistance core needs to warm before casting. Now, as I told you, gas evolution high, it is a less. Normal cold, it is compared with the cold box. The hot box resin used at 1.4%. The gas evolution is always less than cold box when cold box total usage is 1.3%. So this is about that. This kind of cores can be produced, they are produced by using the hot box process. Now cell process, this is very much popular for the critical castings in India. I can say for making the molds and cores by Indian foundries, the 50% consumption is of the cell resin. If India is consuming around 2,000 tons of the resin binders, organic binders, Indian foundries using, out of that 1,000 tons is the requirement of the cell resin. So that much popular this process is, and still it is a versatile process. or among all the processes. No doubt it is having certain limitations. We will come to that also. These are the silent features. Why it is more for silent features of the cell process. Industry trend means demand is there, advantages are definitely there. No doubt with advantages, disadvantages are there. What kind of the raw materials required, I have mentioned over here. Then how to make the resin coated sand, we have mentioned, and to get the proper resin coated sand, what should be the process control parameters that I have highlighted. What is the advantages? It's a dry fluid flowing mixture. Other processes you will find sand is mixed with the resin components and that mixture becomes wet. That is not with the cell. It is a dry fluid flowable sand. On the contrary, fluidity is better than more than the base silica sand. Excellent fluidity, that's why it requires less shooting pressure compared to other processes. Can use very fine sand. You see, in case of cold box or Nobel or any other process, there is certain limitations of the fineness of the sand. For cold box, one has to use 52 AFS sand with the 52 60 AFS number. For Mobile also same. Here you can use if sand having the AFS number than the 100, more than the 100. So this is the beauty of the process. Then excellent casting finish, because this process is having a higher strength. So draining, cleaning, the sand fusion problems are comparatively less with the cell process. Then accurate dimension of the casting, because curing happens more or less 100% curing is happening inside the core box or pattern. So accurate dimensions are there. This process is having the higher thermal stability. That's why it is used for producing the critical castings of the cylinder head, cylinder blocks. Yeah, in case of a larger casting, critical cores like oil gallery cores, water jacket cores, like that. Then hollow cores possible with this process, uncured sand one can take out very easily by inverting the core box. Low sand to metal ratio. In case of other process, you can find the sand to metal ratio maybe 1:1 to 5, 4, 6 like that. Here, it may be less than 1 also, 1:0.9, yeah, 1:1. That's the idea. Then storage of the cores is a very high. They are humidity resistant, so one can store for the longer months. And coated sand is having indefinite shelf life. Means if that sand is stored away from the heat and moisture or water, one can use for making the molds and cores that sand even after 1 year. So that kind of the beauty is there. External surface finish of the casting will be there, dimensional accurate casting will be there, and cell process upon easy means critical patterns where pockets are there, the ribs are there. So that kind of the molds and cores can be prepared by using this process. Hollow cores are possible here. Ease of handling, sturdy cores you will get, sturdy molds you will get. One can transport from one place to another place without much of the damage, because scratch adhesion, all these things are much better than other process. Resistance to moisture pickup, it is then simple process. Layman can produce the molds and cores with the resin coated sand. No skill is required. Excellent fluidity, as I told. Low shooting pressure is about 2 to 3 bar pressure will be sufficient to make the molds and cores with this process. High out of box strength means after ejection of the molds and cores, you will find a much better strength. And because of the high strength, because of the best surface finish, less inclusions are there, and no doubt inbuilt this process having high thermal stability, so we will get the dimensionally stable castings. Most of the small castings doesn't require any refractory wash to get the better surface finish. Because one can go for the fine sand and will get the best surface finish casting. So there is no necessity to use the refractory coat over the molds or cores. Then later on, no pattern wear, longer shelf life, low capital investment because shed sand is available from the market. In case of shell process, base sand can be easily changed to suit the specific requirement of the casting. That is not happening with the other process. Maybe for box, they are obeyed. That is not happening, but with this, it is happening. And economics. What are the disadvantages? High cost of the process, high cooling cost because all the coolings are metal, high energy cost. For cooling, it requires either LPG or electricity. So cooling requires cooling cost is very high. Then long cycle time. Long cycle time, I mean to say, when you compare with the hot box, warm box, and cold box, here cooling cycle time is almost double. So that's why I mentioned it is a long cycle time, and it is applicable, usable for the limited casting weight at the most for the 20 kg. What are the raw materials used for making the silica resin coated sand? Is the silica sand, required sand, aluminum silicate sand that is called as the ceramics, pomade sand for specific applications, phenol formaldehyde and rock resin. Then hexacatalyst with lubricant and various additives to get the specific properties to avoid the specific casting defects. So these are the typical properties of the silica sand used for making the resin coated sand. Grain shape round to subangular, clay content max 0.2%. Chloride should be 0, carbon should be 0. Means that sand should be free from the impurities. Acid demand only max less than 6 ml of the KY per 100 gram. Means sand should be neutral and little bit acidic. Silica content below 98% because silica content decides the refractiveness of the sand. Loss emission of the best solid sand should not be more than 0.2%. And AFS in the range of 50 to 80%. No doubt, some of the cores may require a coarser sand of AFS number 30-35. That is also possible. And 3 acid distribution, minimum 80% retention on C conjugate distribution. And loose bulk density of dry sand should be 1.4 gram per cc minimum. Otherwise, lighter sand will require a higher binder amount, and that will create the problems with the molding, core making, and casting. This is the process how to make the resin coated sand. Resin coated sand is produced by warm air process, hot coating process, ignition process. Ignition process was the old days, outdated process in old days when there was no specific equipment. So people were putting the sand resin in the ordinary mixer molar and lightning, and they are burning the photo solvent is there. They are getting the sand. In that case, lot of binder will get burned. And carbonate material was contaminated with the resin coated sand, and that was giving the much problems with the molding, core making, and castings. Then warm air polish that is very much popular in India and worldwide also, where liquid resin is used. It requires specific mixer having the hot air passing provision, and then it is with the hot air means you have one charge the sand in the mixer, then followed by the hexacatalyst, then resin mixed with first dry mix with the hexacatalyst, then wet mix with the resin for certain time, then pass the hot air at the temperature of 200-250 degrees Celsius to evaporate the solvents whatever they are in the resin binder. And after that, you will get the free flowable sand that will be in a lumping form. One has to discharge over the lump breaker, and after lump breaker, that lumps will get break down, then screening, and then storage in the silos in the bags. This is the warm air process. Recently in India, no doubt it was popular in the Europe and developed countries. In India, recently, few manufacturers adopted hot coating process where solid resin is used and sand is created to the certain temperature. Then with that sand, solid resin is coated with the sand particles. Then mixture is quenched with the hexane solution. That hexane solution with the water at a lower temperature, and then lubricant is added, and you will get the resin coated sand of a better quality than the warm air process. These are the process control. Phenolic resin, one has to ensure about the phenolic resin quality. Then one has to ensure about the formulation. Formulation, I mean to say, what should be the FS number of the sand, what should be the percent of the resin, what should be the percent of the hardener. Here is there requirement of any specific additive, that is the formulation. Then core and pattern and core box equipment, operating temperature, dwell time, over times, release air spray, pattern and core box sealing, mold and core assembly like this. Because all these factors affect your mold quality, core quality, and at the end casting quality. Quality of the coated sand is, means this particular self-coated sand is determined by the stick or melt point. We are talking about the melt point, the stick point. The temperature at which the cell sand sticks to the heated bar under standard condition. The stick point indicates rate of the build-up. Means how much thick mold and core will get, that is decided by the stick point. Normally stick point range is 98 to 102 degrees Celsius. In terms of the Fahrenheit, it may be right from 206 Fahrenheit to 240 degrees Fahrenheit. Then hot tensile strength. It indicates the hanging strength of the cores molds without any deformation. Large cores, high temperature pouring casting required a high strength. Loss of emission. That loss of emission indirectly indicates about the binder of content in the resin coated sand, means how much binder is there with the hardener. That is decided by the loss of emission, and also indirectly that tells about the gas evolution of the core, SL sand. Hot distortion, it is the specific test that gives idea about whether that sand is usable for the critical cores used to be used for the water jacket, oil gallery, or hydraulic casting, or whether that core may result in a casting defects like the pinning, or like that, crack. So distortion is important test for with that angle. This is a troubleshooting of the resin coated sand. The foundries who are using this resin coated sand, they are may have faced this kind of problems. Spillback means first when you are producing the molds with the dumb box, hollow cores, we will find this kind of the things. Out of course, part of the core box means some partially coated sand falls in a dumb box like that. High it is happening, possible causes hot or cold spots in the core box or on the pattern. That means uniform temperature is not there, uniform heating of the pattern core box is not there, and that's why feedback problem may arise. Then entire core box itself is too hot or too cold, because you see, for curing mechanism, temperature requirement may be around 200 to 220 degrees Celsius. Your tool temperature may be 250 or 300 degrees Celsius or more than that. It may be 150 degrees Celsius. In that case, partial cured sand is going to fall out, and that is calling as a feedback. So one has to ensure about the temperature. Then low melt point of the sand. Why it is happening? One is the low temperature of the hot air at the time of sand manufacturing. There may be misproportion of the resin and hardener in the formulation. Yeah, there may be the faulty resin and faulty hardener. That's why that sand might have resulted in a low melt point. Then box core air pressure is too high or too low. When you are going to shoot at the high temperature, high pressure, definitely there is a chance of the separation of the binder on the sand grains, and that will result in a certain grains will be with a without resin, and that may result in an inclusions in the castings. Then, as I told, sand should be dry, resin coated sand should be dry. If that sand contains the moisture, then fluidity is getting affected. We'll observe the uneven curing and uneven compaction of the molds and cores. Then, in a winter, cold sand chances are there, and if sand is cold, it will require the more temperature, more time to form the mold or core. And that sand is also having the low fluidity, and that will result in a core compaction. Then dirty pattern of core boxes. Why it is happening dirty pattern of core boxes? Because of excessive uses of the parting reagent. Then high shooting pressure, when there are the chances of separation of the resins from the sand grains, and that is going to deposit over the surface of the core box and patterns. So that's why pattern that suddenly become dirty. And then fanning and thermal shock. Sometimes you find very fanning type of the defects in the casting. So why it is happening? You have fixed the formulation of the resin coated sand. Irrespective of that, you are getting this kind of the defects. That means your pouring temperature is high. You have to control the temperature. Yeah. During the storage of the cores and molds, some trace might have been developed with the mold and core, and that trace, though it is not visible with the naked eye at the room temperature, but when that mold and core comes in contact with a molten metal, that will get expanded, and that will result in a veining, and sometimes some leakages of the molten metal will be there. Then cores or molds are excessively brittle. It happens because of if there is a misproportion of the resin and hardener, more hardener units are there, the cores, the molds become brittle. So normally, 16 to 20% of the resin is the ideal requirement of hardener. If it is a more, that definitely results in a brittleness, and brittle molds, brittle cores, chances are there of the mold leakages. Yeah, some veining will be there. Then base sand does not allow for the enough expansion. As I told in case of the silica sand, ground grain sands are having more tendency for the veining. Irrespective of though they are giving the better strength, but they are in the tendency of the veining. So we have to blend little the angular sand with the round grain sand to avoid this defect. Then uneven mold bonding. Check to see if locators are lining up proportionally. Then check storage conditions. Locations means ejector pins level is important, I mean to say, because if uneven force that trace is there, it is going to happen some individual cracks going to form over there, and they may expand when they come in contact with the molten metal. Then core or mold weights are too low. It is happening because of low investment time or low dwell time. So one has to adjust investment time and dwell time to get the proper desired weight. Then core or mold have a thin wall spots. Then it happens because of the feedback tendency of the resin sand. So one has to study what are the remedies for this for the feedback that one has to refer. Uneven built-up. Built-up means there is a standard test developed by the BCRA, that is Cast Iron Research Association. So overheat distribution means if heating of the pattern and core box surface is not improper, it happens. Where temperature is high, you will find the more built up over there. Where temperature is low, you will find the less built up is there. Then core dent, core length. In case of making the hollow cores, when you invert the core box, sand should get out very easily. But if it is because of the intricacy, it is not getting easily out, then one has to make the provision for the vibration, little vibration, tapping. So that will help for the getting uncovered sand out. Then dirty patterns and core boxes, we discussed this about. Poor blow pattern, check the locations of the vents and blowers. This is the normal thing I have observed in various foundries. Vents are there, some escape shades are there, but that vents are not maintained properly. And over the period, that vents are blocked because of the fines in the sand and because of the separation of binders over the vent surfaces. So there should be the periodical schedule for cleaning and changing the vents. This is applicable to for the plug vents also. Then lack of built-ups means being a heat cured process, all the parameters are related with the temperature and time. So high built-up is less. If you require the 10 millimeter or 6 millimeter thick mold and it is coming less, height is less, your temperature of the core box or pattern is less. That's why it is coming less, thickness is coming less. Then melt point of the sand is too high. Why melt point of the sand is too high? One thing is there, it is a disproportion of the resin and hardener while making the resin coated sand. Hardener may be more than desired, and that will result in a high melt point of the resin coated sand, indirectly low buildup. Then cold sand, if cold sand is too cold, buildup will be low because during your given time of the dwell time, some time will be consumed for increasing the sand temperature, and time required for build-up will be less. Then too short an investment cycle. So investment cycle means dwell time you have to increase. Then cold box or pattern, raise the cold box and pattern temperature. Excessive build-up and poor fluidity. It is the vice versa of earlier these things. So high temperature, then melt point of sand is too low, like that means whatever we discussed in previous, that is vice versa of that is applicable over here. This is important for poor fluidity and blowability. Well, actually, when we make the cores molds by shooter, in case of that, sand is pushed inside the core box along with the air. If that air gets stuck up, accumulated inside the cavity, then that will make the obstacle to the sand, to the better compaction. So, fainting, cleaning of faint, area of faint is most important for getting the better compaction or best compaction of mold or core in any binder processes. If faint area is less, same problem will be there. Then too hot pattern of core box is there because of the radiation of the heat. In a grow area, some of the sand particles may get cured and that will going to affect the fluidity. Then moisture in the air. This is a common thing I observed across the boundaries. If air contains certain moisture, that moisture get contaminated with the resin coated sand and that affects the fluidity of the sand. Then insufficient amount of the release agent in the sand is talk about the hardener. Hardener is the blend of hexamine and lubricant. So that lubricant amount is less, then fluidity, that affects the fluidity. Metal penetration. All other means whatever problems we observed earlier means poor fluidity, then uneven cooling and all these things. Definitely all these problems, if we not address, they will result in this kind of the casting defect. Core not blown days. I am always talking about the compactness of the core, means density, compactness, uniform density, that mold and core should have uniform density. Then surface of the core or mold too brittle. It happens because of a high edges of the hardener in the formulation. Then sand too coarse or too open, means coarser the sand, chances of metal penetrations are there because voids are more with the coarser sand. Casting porosity means it is related with the gas and all these things. If curing is not a perfect, some molds and cores are under cure, means surface may be okay, but under the surface there are chances in case of a thick core or mold, chance of uncured sand is there. And when that sand comes in contact with the molten metal, it starts liberating the excessive gas, and that will result in the casting porosity. Excess gas generated at the metal and sand interface decrease the resin or hexa level. Then porosity of the base sand is too low. That's why in case of sand, I emphasize on the fines content. Anything passing through 140 mesh is a dangerous thing. Irrespective of the AFS number and all these things, suppose your sand is having the AFS number of the 50-55, but that sand is having means sim distribution of that sand is having minus 140. If it is a 5 to 10%, definitely irrespective of the AFS number, that sand is going to give the problem, this gas porosity problem. Then inadequate fainting of cores and molds. So fents are most important in case for any core box and mold box. Front area is the most important to get the good quality of the cores and molds. And if you get the good quality of the cores and molds, your castings will be much better. Need for the gas scavenger. Sometimes pinhole type of the porosity is arising irrespective of the total gas evolution. So one has to incorporate little bit of red hematite iron oxide to avoid that kind of the porosity. Sticking to the sticking. Core or mold is overcured. If that is happening, what happens? Overcure, if overcuring is there, That means that the ore or mode has lost certain strength, and that will definitely wash with the flow of the metal and will stick over the surface of the casting. Then the release built up in the core box or pattern. For better release of the pores or molds, we are using the release agents. So uses of that should be well in control, because the contents in a release agents are non-volatile. There remains over the surface of the molds and pores. Insufficient release agent in the sand, that is related to the lubricant. In the last earlier slide, we have discussed about that. Then free resin in a resin coated sanding happens when where actually resin coated sand is manufactured by either by a hot coating process or warm air process. In both the cases, in warm air process, if your hot air temperature is less, that resin will not going to mix with each and every grain of the particle of the silver sand, and some free resin will be there. And in case of hot coating process, if sand temperature is less, the resin will not melt at that temperature. 100% melting will not be there, and some globules of the resin will be there, and that will remain as the free resin. And dusty resin coated sand, the sand prepared by overmulling over time, that will generate in a dusty, and when if more dust is there, sticking of the sand particles over there with the pattern as well as casting. Weak means there are certain observation pores and molds are during the handling they are breaking, during the pouring they are breaking. So that means strength is not sufficient. Why strength is not sufficient? The proportion, resin percentage and hardener percentage is not as per requirement. If hardener is less, strengths are less. If curing is over cured, strength will get decreased. And one has to be very much sure about the proportion of the resin and hardener, as well as desired quantity of the resin and hardener, and also the temperature, curing temperature of the patterns. High melt point sand we have discussed with errors of that low melt point sands. So why it is coming? The sand is too cold. One has to increase the hot air time to get the desired sand temperature should be around 60 degrees Celsius. If it is a less than that, then one has to extend the hot air time. Increase the sand temperature. Then pre-mixing, dry mixing means sand and hexa. One has to ensure for the proper mixing. Then sometimes what happens, blowing air, that air, if that is contaminated with the air, moisture, that will also decrease the melt point, the stick point of the sand. And ultimately, the resin quality is also important. The resin with the low melt point will result in a low stick point of the sand. High melt point, it is a high source of failure. Free resin, we discussed about the free resin, and this is the most dangerous in case of the hot coating. The sands prepared by the hot coating process, there are chances of the free resins into the sand, and that free resin results in casting defects like blowholes, gas holes, and corrosion. Lower tensile, again resin content and all these things will be get checked. Okay, now we have covered the heat cured processes, hot box and cell process. Now we will discuss about the no-bake binders. No-bake binders means the binder system which develop the strength at the room temperature. There are a variety of the no-bake binders. Among the phenolics, it is a two-part phenolic, acid cured, phenolic ester cured, that is called as alpha set, then phenolic urethane, that is called as pep set, then one more furan no-bake is there, and in past there was one more no-bake process, that is the alkyl isonic three-part no-bake process. So except alkyl isonic three-part no-bake process, all the binder process we will discuss over here. So among that, first is the phenolic acid two-part no-bake process. Some 15-20 years ago, this was the popular process adopted by most of the Indian foundries because of the availability and the economics. This was the most popular process after alkyl isonic three-part no-bake process in old days. So resin is the phenol formaldehyde dissolved water-borne type. Hardener is the sulfonic acid, is the strong acid. So one has to take care while handling the resin and hardener components. All the safety measures should be used. Process is sensitive to the sand quality and ambient conditions. Why it is a sensitive to sand quality? Because CC, its name itself indicates it's the acid cured system. If sand is having a high acid demand value, if sand contains some alkaline earth metals, the sand is having a high pH value, maybe 8, 9, 10 like that. So definitely the performance of the system is going to affect, and that may result in a low strength, longer bench life, priority of the molds and codes. The uses resin is used at the level of 1.5 to 2% of the sand, that is a fresh sand, and for reclaimed sand, mechanically reclaimed sand, one can reduce the binder content right from 0.9 to 1.4%. And catalyst uses, that is in between 30 to 60% of the resin. Depending on your catalyst uses, is decided by the size of the molds, size of the core, then your dripping time requirement, whether that is with a flask or without flask. So it is decided by the percentage decided by your requirement. The bench life of the mixed sand is 5 to 20 minutes, and steeping time right from 10 minutes to 4 hours. For large molds, the molds which are in weight of the molds more than the ton in terms of tons, that mold required more time to strip. So that may require maybe 4 hours. Now, here some tips I have mentioned at low temperature, particularly in the winter. Low reactivity, low strip, and difficult to cure. Means sometimes it happens at the low temperature, when temperature ambient temperature is 2 degrees or 3 degrees Celsius, sand temperature is also low. One has to wait for the overnight to strip the mold of core. That much effect of the ambient conditions is over here. Limited shelf life of the resin. A resin shelf life is hardly 2 months, and manufacturer always recommend to store the resin in a cool and dry place, if possible in a cold storage. Storage of the resin in a direct sunlight will again reduce the shelf life, maybe less than 2 months, one like that. And when it happens, viscosity of resin changes very fast with the temperature. In suppose that supplied resin is having before viscosity 30 seconds. If that resin barrel is stored in the sunlight. After 1 month, that viscosity may be in a few minutes, 3, 4, 5 minutes. And one point or one time will come that resin water starts separating from the resin, and that resin becomes useless. So storage of resin is the most important with this process. A choice of hardener is important due to the sulfur content. As I mentioned, hardener is the sulfonic acid. Sulfonic acid is derived from toluene and sulfuric acid. So there are chances of the free sulfuric acid in the hardener. So for ductile iron or for HG iron, it is important to select the proper hardener. Otherwise, the casting will get rejected due to the demineralization of the graphite. Then this is the ideal process substitute for the furan-Novik process. Furan-Novik is comparatively costly, and one has to depend on the imports of the raw materials and resins. In India, phenolic acid Novik is easily available, so this is ideal substitute for that. Then, while using the resin component for making the molds and cores, never add resin and hardener simultaneously or mix together, because that reaction is very much exothermic. So chances of accidents are there, fatality are there. So this red line instruction should be followed strictly. What are the advantages of two-part acid Novik? Comparatively low cost process, easily available, high air pure strength, high hot strength, nitrogen free systems. 80% of the sand reclamation is possible by mechanical addition process. Flashless molding process is possible. But like advantages, some disadvantages are there. Limited shelf life of the resin at the 2 months. Strong acidic catalyst is required, sulfonic acid. So corrosion, facts will be there. Sensitive to the sand quality and ambient. So seasonally one has to select the catalyst, type of the catalyst and percent of the catalyst. Medium to long stick time is there, so one can produce 1 kg mold of ore to few tons of mold of ore. Sulfonic acid is there, free sulfuric acid is there, sulfur emission is there. Then odor or irritation during the sand preparation chances are there. Then this is another Novik process. So day by day, this process is becoming very much popular for the steel foundries, to some extent steel giant foundries, and some extent aluminum foundries, sand casting. This is a phenol from an alkaline dissolvent. Hardener is a blend of organic esters. In earlier process, hardener was the acid. Being an alkaline process, alkaline regime, the process is less sensitive to the sand quality and ambient. Wide range of hardeners available to control the bench life and strip time. Ideal process for the steel castings. The process is totally nitrogen and sulfur free. Various versions of the resins available to suit the customer and casting requirement. Then uses 1.5 to 2% of the sand, hardener 20-25% of the resin. Bench life one can get 5 to 15 minutes and shipping time 15 to 2 hours. Here I would like to mention one thing. Reclamation of this alpha acid reclamation level is comparatively less than a phenolic acid profile, 60-70%. In case of phenolic acid profile process and furan process, unit sand uses of the unit sand is possible, whereas here reclaimed sand should be used as a backing sand, and for sketching, one has to go for the fresh sand. Otherwise, over the period, accumulation of the being alkaline process, accumulation of the alkaline metals in the sand system may result in the surface pitting defect in the plastic. This is one kind of mold produced by the alkacid. What are the advantages? Water soluble resin, very simple cleaning. One can boil the hands with the tap water. No irritation or smell during the sand preparation. It's a totally nitrogen and sulfur free process. Less susceptible to the sand quality. Sand with a high acidity content can be used. Little moisture in the sand does not affect the strength. So normally the foundry using alphajet process with the continuous mixture. That means there is a provision for putting the water in the system. Then alkaline sand like alluvium can be used. Excellent release of the patterns, excellent hot strength, good resistance to the many and metal penetration. These kind of defects are comparatively very less with alphajet. No lustrous carbon generation, excellent casting finish, best process for the steel. Disadvantages are there. Limited shelf of the resin, 2 to 3 months. Again, resin have one and to store resin under the roof away from the heat and light. Resin viscosity increases with the age. Air fewer handling strengths are comparatively low. Room temperature strengths are always less than phenolic acid noble, pepsate, and furan noble. Moderate level of mechanical sand reclamation, like here in the case of phenolic acid, I have mentioned 80% of reclamation is possible. That is not possible over here. 65 to 70 at the most is possible there. Accumulation of alkaline metal salts in the clay sand sometimes causing a pitting defect on the plastic surface. Now coming to the furan opaque. Few foundries in India they are using furan opaque. Particularly this process is this kind of the resin is used by the foundries who are making the large castings required by the windmill or like that. They use castings. The process is similar to the phenolic acid opaque. Resin is urea formaldehyde copolymer or phenol formaldehyde copolymer. And hardener like phenolic acid opaque, it is a sulfonic acid. Urea formaldehyde copolymer resins contain nitrogen. That nitrogen content varies from 0.5 to 10%. And whereas phenol formaldehyde FA copolymers resins are nitrogen free. And recommendations are like this: for steel nitrogen level 0 to 0.5% is okay. FA content should be more than 90%. For AGI nitrogen level 1 to 2.5%, FA content 75 to 80% is okay. For gray iron nitrogen level 3 to 6%, FA 65 to 70% is okay. And for non-ferrous, nitrogen level 6 to 10% and sulfur alcohol content 6 to 7% is okay. Water content in furan resin varies from 0.5 to 20%, and higher water content is also one of the culprit factor for the success of furan opaque in the foundries. Uses resin as low as possible 0.6 to 1.6% to 1.5%, hardener 30 to 60% based on resin. Bench type one can get 5 to 20 minutes and stick time 20 minutes to 2 hours. Again, points to remember: selection of the proper resin and hardener when is a must. The resins with the higher nitrogen content may result in a bad casting results for the steel and AGN. So one has to keep in mind, but while proofing there is what should be the nitrogen content, what is the moisture content. Then hardener used for making the casting in agile. Sulfur level is the most important. So one should have this kind of the knowledge while procuring the resins. Never add resin and hardener simultaneously. Do not mix resin and hardener together. Use separate containers. Again, it's a spontaneous reaction, spontaneous exosomal reaction, and may result in a catalytic. What are the advantages of the furan? Better shelf life, low viscosity resin. Compared to phenolic resins, furan resins are of a low viscosity. Lower odor and smoke during the casting. This comparison with the phenolic resin. Wide range of resin and hardener available to suit the requirements. As I mentioned earlier, air cure and mass strengths are higher. Good dimension accuracy of the casting, high reactivity, and fastest molding possible, high level of mechanical scientific more than 90%. Few foundries are using 95% of the frame and only 5% frame is used. Strength, yeah, third, curing characteristics are much better than phenolic acid model with the furan. Disadvantages, procurement is always important. No company is manufacturing in India, so it is a very much price sensitive. Curing time is sensitive to ambient like furan acid model, little binder on tendency to gain and particles. Gaining tendency is there with the furan. Hardener is strong accident corrosion, so safety measures for next product and sulfur emission is there. So all these are important factors while using the furan. Here I have mentioned some comparative data, fresh sand and reclaimed sand. First is the bench slide and reclaimed sand. With the fresh sand, reaction is slow, whereas reclaimed sand being acidic in nature, reactions are fast. So one will get longer bench life with the fresh sand and longer stick time with the fresh sand compared to the reclaimed. Same thing is happening with the strain developments. Acid demand value, we are talking about the acid demand value of pH value of the sand. More the acid demand value, you can see the effect over the bench life and stick time as well as strength. Whereas the acid demand value goes up, you'll find the longer bench life and stick time, and also that affect the strain development. With a high strength with a high acid demand value sand are always low. Effect of the sand temperature in case of the Novec, Podbox, Novec, sand temperature is also important, and that's why I'm told in phenolic acid Novec, if sand temperature is lower, 2 degree, ambient is 2 degree, one has to wait for the overnight to keep the mode of 4. So here, this is the graph. 10 degree what is happening, 20 degree what is happening, and 30 degree what is happening. This is a phenolic curation Novec that is called as a website. Very few foundries in India, some few foundries that may be steel, cast iron, aluminum foundries, they are using the website system, Novec, phenolic curation Novec process. This is more or less like the cold box process. It's a phenolic resin, hardener is the isonate, catalyst is the amine over here. Only thing curing is at the room temperature without passing the gas. Here, the catalyst is used in a liquid form. But Among all the Nobel process, this is the fastest process. And here, bench strength to stick time ratio is very high. Here I can mention one thing: if bench strength is 4 minutes, one can strip that mold at the 6th minute. That is not happening with the other Nobel process. There, if in other Nobel process, bench every 10 minutes, one has to wait for 25 to 30 minutes to strip the mold or more. So here, it is curing is happening by chemical reaction 100%, whereas in other process, ambient air also plays the role in the curing mechanism. So it is a 3-part process. Resin is the now formaldehyde with the solvent, hardener is the polymer glycinate, and catalyst is the liquid amide. Resin and hardener are responsible for the strength, and catalyst is responsible for the bench strength and stick time. Uses resin, one can use right from 0.5 for the aluminum casting, 1.2% for the steel castings, same percentage with the hardener, that means isolated, and catalyst 3 to 10% based on resin. Bench strength you get 2 to 6 minutes and stick time 4 to 8 minutes. This is the best process with the performance will be much better with the continuous. What are the advantages of this process? Highest bench strength stick time ratio. In earlier slide, I have mentioned bench strength 2 to 4 and stick time 4 to 6. That will indicate the bench strength stick time ratio. Excellent shelf life of the binder component. Except furan Mobec, I have mentioned phenolic acid Mobec and alpha shelf life is 2 to 3 minutes. Here, one can store the binder compounds to 6 months. Lower binder addition, hence less gas evolution. As low as 0.5 you can use, so gas evolution will be less. Faster rate of curing, metal can be poured up to 4 hours. So, true chemical curing is proved by true chemical reaction. So, faster curing rate. Higher strength, excellent thorough cure helps for the fastest molding. In old days, one of the steel foundry was using this process with the loop line, FLL line without any flux. Partial substitute for the shell core is possible with this process because high strength and better surface use of the cores and castings. Excellent shakeout. Sand reclamation is easy. Normally, few foundries are doing the reclamation by mechanical and few foundries by thermal reclamation. Good surface finish of the casting suitable for all types of materials. Disadvantages are there. Irritation at the time of sand preparation will be there because of the pre-monomers. High odor and smoke during the pouring because one of the components is isocyanate polymer that results in a high smoke. High VOC, volatile on combustion of the solvents. 50% content is of the solvents, so high VOC is there. Sensitive to the moisture because hardener is isocyanate and isocyanate is having the more affinity towards the moisture. So its system is sensitive to the moisture. Pattern stripping may be difficult due to the fast developments. So one has to take proper precaution at the time of stripping. Otherwise, pattern will get jammed. A damage of the pattern may be there because stain development is completely very fast. Lustrous carbon generation during the pouring is there because of the polymeric acid. And comparatively, it is having the low stain and these molds and pores may give the problem cyclopenic in the customer. Effect of the catalyst on bench time and stick time here. Uses of 0.4% and 0.8% slot of catalyst, what is happening for the bench time and stick time I mentioned. Sand temperature, being a Nobel process, sand temperature plays a vital role here also. Sand quality, acidic, neutral, and alkaline. What happened? I have mentioned over here. This is the core, special core. This is a class test look like, and that's the rollover table to remove the molds from the pattern. This is the comparative behavior, phenolic ester in sulfate, furanobate, phenolic acid, phenolic urethane and alkyl part. Odor at the machine in phenolic ester is a moderate, furanobate high, phenolic acid high, peptide is a high, alkyl part is a moderate. Pattern release excellent with the phenolic ester. A phenolic novel, it is a poor, means sometimes sticking of the molds or pores to the pattern chances are there. Phenolic acid same, phenolic urethane peptide is same, and alkyl is easy. Water cleanup, it is possible. Furanobate partially, phenolic possible because both regions are with the water content. That's why partially possible. Phenolic phenolic urethane is not possible. Alkylate is not possible because one of the component is the polymeric isolate. Bench type stick time ratio in phenolic ester is 30-35%. Furanobate 35-40, little bit better than phenolic ester. Phenolic acid, it is like a furan. This is at the ambient conditions are 30, that time ratio. Phenolic urethane novel means peptide is a very high, alkyl it is a like albacete. Effect of the sand quality, phenolic ester it is a very less effect. Furan being acidic for process, very less. Effect of the temper is very high. Phenolic acid it is a very high, and phenolic urethane no doubt it is a very high because of the acidic, and alkyl 3 is less. Reclamation with the phenolic acid is a moderate. Furanobate is a high. Rest of the process is a high. Then this is the related with the casting performance. Alpha set scab tendency is a low. Here possibility is there with the furan, phenolic as well as furan. Then peptide also and alkyl also. Sulfur in albacete there is no chances. Here because of the sulfonic acid chances are there. In peptide no sulfur, alkyl acid no sulfur. Training very low in albacete. High tendency with the phenolic acid and phenolic acid. Peptide it is a little comparatively low, and the liquid 3-part model it is a low. Gas defects with albacete they are low because that is a little bit some of the resin compound contains some inorganic chemicals, so gas defects are low. High absorption is there. Then in case of phenolic acid and furan model it is a moderate. Then in case of peptide it is a high. And alkyl 3-part it is a high because of the polymeric isolate. Then check out means it is a good with the albacete and the phenolic acid and furanobate it is a moderate, peptide it is a moderate, rest of the moderate. Lustrous carbon defect. With albacete there is no very low, chances are less. Whereas furan and phenolic acid nobate comparatively moderate, but in peptide and 3-part nobate it is a high because of the polymer hardener. Then pour of smoke. With albacete smoke is very less. Furan nobate and phenolic nobate is a less comparatively low, but F-cell can altitude it is high because of the hardener. So till now we have covered silica sand, concrete, then heat cooled binders, and just now no bed binders. Now we will switch over to the gas cooled process. And most popular in India, that is the cold box process, phenolic urethane among cold box process. Why it is called as the cold box process? Because formation of pores are at room temperature, and that too without wasting much of the time. Best process for automobile and ductile pipe castings for the mass production means cycle time. Should to shoot cycle time may be as low as 1 minute per pore. Partially, this process partially replaces cell process and hot work process and some of the Novik course on the Novik process. The process is a three-part process. The process is a three-part process. First one, like a pepsin, resin in the phenol formaldehyde polymer dissolved in the solvent. Hardener is the polymeric isocyanate dissolved in the solvent, and catalyst is a liquid amine like a pepsin. But this amine is converted into vapor phase with the help of gas generator and pass through the pores. The process is very sensitive to the sand quality and system moisture. Cooling is also equally responsible for the success of the process. Uses 0.7 to 1.1% based on sand resin. Hardener 0.7 to 1.1% based on sand. But in case of aluminum foundries, uses can be as low as 0.45. That is also possible. The offset ratio of resin and hardener may be sometimes followed depending on the sand quality, casting requirement, casting defects. That factor decides the offset ratios. Bench life of the mixed sand is 40 minutes to 4 hours, depending on the sand quality and ambient conditions. Core making, the cores are produced with the help of core shooters. So core making blow pressure is 4 to 7 kg per cm square. Blow time to 10 seconds based on the geometry and weight of the cores. Low purge 2 to 10 seconds. High purge generally 5 times the low purge, and purge temperature 90 to 110 degrees Celsius. Actually, a high purge temperature is required because during the cooling mechanism, some of the solvents are getting evaporated. They should be removed from the cores, and there should not be any remnants of the amines inside the core. So, purge air temperature is the most important factor for the success of the process. What are the advantages? High productivity, large volume, high speed production. No tooling heat is required. So, core boxes may be of the plastic, wooden, or aluminum. Cost effective to run in comparison to heat systems. Low labor and energy cost. Actually, in case of ESA, this process is normally mostly it is looked as a substitute for the cell and hot box process. In cell process and hot box process, huge amount of energy is required. That is not happening over here. So it is a one can save the energy cost. Then good dimensional accuracy, no distortion of the cores. Because 100% cooling happens inside the core box at tool. Cores can be handled immediately. 80% of the strength is developed inside the core box. The pores can be handled immediately. Pores can be cast almost immediately. Low gas evolution because binder additions are very less. H1 thermal speeds of the casting. Long shelf life of the sand resin components. That means storage life, the shelf life of resin component is around 6 months. Effect of moisture. You see, moisture is the enemy for this process. First, you see sand without any water. You see the 24 stands, 1 hour, 2 hour, like that. Means and sand with the 0.05% moisture. See the drop and last sand with 0.1% moisture. See there is no strength. Effect of alkalinity on the bench layer. Alkalinity means acid demand value, or pH value of this given sand. First is the neutral sand. Will get 2 or 3 or bench layer. Another one is the alkaline sand that is with some acid demand value. Hardly 1 hour bench lab is there. One hour is also not possible. Drastic drop in the strength is there. Actually, in another word, bench lab means the 30% drop in the strength is called as the bench lab. That is the scientific way to check the bench lab. Then high reactive low dose eco-friendly cold box. This is the recent development in the cold box resins. These low VOC and eco-friendly cold box resins are having the high humidity resistance than conventional cold box resins. Then they are having the high reactivity, means productivity is much higher than conventional cold box, having high strength, low amount requirement is over here, and low snow generation during the casting. That means low VOC and longer bench life of the mixed sand and easy release and less built up onto core boxes. Means downtime, we are devising over the pattern and all this is comparatively very less with this version of the cold box. This is the latest developments among the cold boxes. This is the comparative with the conventional comparison with the conventional cold box and new version, that is the eco-friendly, I can say. You can see the strengths, bench life, and all these things. Disadvantages: toxic chemicals means hardness is a partial calculate. So toxic chemicals, proper care for personnel needed. Poor humidity resistance, limited self of the pores because of the ambient humidity. Lustrous carbon generation during the pouring is possible. 100% dry air needed for blowing and purging. Sensitive to the sand quality, fine sand not suitable because we are passing gas amount as in a vapor phase, so fines may be obstacle and that will delay the filling mechanism. This is the cold box core. This is one more cold box process that is knowledge to guys for very knowledge in India. They use this process for making the cores. This is a phenol formaldehyde alkaline resolve process. Process is less into the sand quality and ambient. It is like I can say like albacete. Ideal process for aluminum and steel castings. Totally nitrogen and sulfur free process. Resin can be used in the range of 2.5 to 4% of the sand and base at 2 hours. You will get the bench at 2 hours. The filling is very slow. It's a non-flammable water washable resin. All resins are flammable, whereas this resin is not flammable. Very low phenol and formaldehyde are there. No toxic ingredients like arsenic, peroxide, amines, or sulfur-based compounds are incorporated in the process. No toxic fumes during the mixing and core making. Any type of sand can be used. So some of the defects, inclusions, because of the low strength, moisture in the air, then improper hardness, resin proportion that results in the inclusion defect in the casting. So one has to take proper care of about the quality of the sand, quality of the air, and process parameters, control the process parameters like that. Sand fusion. This is because of the low compaction, coarser sand, air in the moisture, the low percent of the resin, low strength, coarse, molds made, prepared after a base life of the sand. This kind of the problem will occur. Gas defects. Sometimes what happens because of the higher uses of the higher percent of the binder components, hardener component. Improper mixing of the resin component with the sand, globules of resins may be there in the mix, and that will result in a gas defects. Very high percentage of fines in the sand will defect results in the gas defects. Shrinkage. Shrinkage defect because of the binders. One of the reasons for the shrinkage is the low strength. Low strength because of the poor quality of the sand, high fines in the sand, and air in the moisture in the compressed air in the sand. Okay. So for answering this, proper selection of coating and its application is very important. In Cerebrals, we have developed state-of-art coatings, many much specialized applications for different uses. Thank you. I don't
Different organic binder processes, their advantages, disadvantages, and process parameters. Thank you, sir. Thank you for the excellent lecture.